Greetings to you all grade 11s, matriculants. I hope you all good and welcome to Pursue Excellent Tutoring. And at this time, we'll be looking all over this particular theorem that you are seeing here all over the screen. Theorem that states angle at center it is equals to twice angle at the circumference of the circle. Of course, if you need some further assistance regarding mathematics, do not hesitate to hit me on the number above or my email above as well. Okay, so boys and girls, without wasting any course of time, just allow me to take you through the entire proof, whereby you'll be grabbing some techniques to consider when you prove this theorem. In words, we said the angle at the center of a circle is double the angle at the circumference of the circle subtended by the same arc or chord, right? So this is just the statement that is representing this particular theorem, right? And it is quite important for you to master it, because they sometimes omit some important keywords between expecting you to fill in. So you have to note that. But just in short, it's just representing angle at center equals to twice angle at circumference. Okay. So on your exam room, you will be given this diagram that you are seeing here on my left hand side, together with the statement. The statement, it is RTP, required to prove, right? So you just have to continue from there. So as you can see here, we have the RTP, or required to prove. They want us to prove that the angle AOB, we're talking about this angle O between A and B, letter A and B, it is equals to twice angle ACB. ACB is the angle C between letter A and B, and this angle that you're talking about is the angle at the circumference of the circle. So they want us to prove that this angle at the center, denoted as AOB, it is equals to twice angle at the circumference of the circle. So what you need to do when you prove any single theorem, you have to write the construction as the first approach. Construction. On your construction for this theorem, we have to draw CO and extend it. You can denote any letter here, boys and girls. It is not necessary for you that you have to put this particular letter, unless if it is stated otherwise. Okay, so I'm denoting the letter N here. I'm drawing a CO and extend it to N. I'm extending it to N. Okay, let me do it practically on my diagram so you can able to see. I'm drawing a line from C to O, and I must extend it from O to point N. So put in mind that it is not all about this letter N. You can put any letter here. I am done with the construction. So when I divide this, we have got these two triangles that we are going to consider when we prove this theorem in detail. Okay, before that, let me name my angles here, because I divided this angle C into two sizes. So here I'm going to write, this is my C1, this is my C2, and O1, this is my O2. Then after the construction, now I have to prove in detail. So whatever that we are going to do now, I am going to focus on these two triangles. The first triangle is this one, the triangle which is AOC. AOC. Okay, let me try to draw it here aside so you can see this is C1, this is AO1. Okay, so let's try to have a look on this triangle side. Since we extend this line from O to point N, in other way around, we are going to have this exterior angle of a triangle. And remember that the exterior angle of a triangle, it is equal to the sum of two opposite interior angles. Okay, so this O1, it is equal to the summation of angle A plus the C1. Write it. Write it here. This O1, it is equal to the sum of A plus the C1. The reason being this is the exterior angle of a triangle. Exterior angle of a triangle. Okay, but C1, it is equal to this angle A. I hope you will agree with me here, boys and girls. Let me show you something here into this diagram in detail. Remember that any line drawn from the center of the circle to the circumference of the circle, it is representing the radius. So this OA together with OC looks the same, okay? And if they are equal, as a result, this would be an isosceles triangle. An isosceles triangle, you know it very well that as a result, this angle A, it is equals to this angle C, right? This is exactly what I'm trying to emphasize here. Okay, so this C1, it is equals to angle A because this OA, it is equal to OC. Their radius here, this the equal radii. Okay, so we can just write this as your reason there. So just because the angle at the circumference that I'm talking, I am going to prove it is in terms of C, so meaning that I must represent this O1 in terms of C instead of this A here, right? I hope it is clear. So instead of continuing with this letter A, I'm going to replace this A by C1 again, so that I make sure that my O1 it is in terms of C. Therefore, O1 it is equals to summation of C1 plus another C1. Okay, what I did here, where there is A, I'm replacing A by C1. Then finally, this actual size of this O1 in terms of C1 is going to be 2 multiplied by what? By C1. I hope it is clear to every one of you. So similarly, you need to do this again, focusing on the triangle, which is what? Which is the BOC. I hope it is clear. I hope it is clear to you all. Let me go to the next page. So I must draw that triangle that we're going to use now. Another triangle that we have to use. It is ON, but do not forget now we're dealing with the O2, C2 together with the my triangle is not in a proper way here. How to draw it? Do this, yeah, something like this. Let me go and check this. No, I'm failing to draw this triangle in a proper way, but don't worry, I will do my best. I'll do my best to fix that. Okay, it have to be like this, okay. This is the letter O to N. Now we're talking about O2. This is the C2, and this is the B, right? So similarly, in this triangle BOC, O2, it is equals to C2 plus the angle B. The reason being is our exterior angle of a triangle. But this angle, which is C2, it is equals to B because we notice that this OB, it is equal to, or C, they are equal radius, the radii. So if these two sides looks the same, as a result, this C2 would be equals to B. So I'm going to do this similarly. Remember that the angle that we're talking about at the circumference is denoted in terms of what denoted as the C, right? In terms of C. So I don't have to continue with this letter B here. So I'm going to represent my O2 as the summation of this C2 plus another C2. At the end, this O2 is going to be twice the angle, which is the C2. Okay. I hope we are all glad. So what I'm going to do now here is to link this triangle AOC together with this BOC, right? Because what they want us to prove now here is AOB. AOB is the summation of what? O1 plus O2. So let me show you. So now the triangle AOB, it is the same as what? It is the same as the O1 plus this O2. Okay, I hope you will agree with me here, ladies and gents. And the angle at the circumference of the circle ACB, it is equal to the summation of what? Of this C2 plus the C1. It's C2 plus the C1. Okay, I hope it is clear. Oh, let's finalize here. The now O1 plus this O2, it is equal to what? Whether it's O1, I'm just replacing by what? By 2C1, because I already proved that. 2C1, where this O2, I'm putting 2C2. So therefore, now, this side I'm going to take out the common factor. I'm left with the C1 plus the C2 inside the bracket. Okay, let me write it here, O1 plus O2. Then now, I'm finalizing, guys. Do not forget that this O1 is the same as this, right? So instead of writing O1 plus O2 now, I'm going to write that AOB, it is equals to 2. Then instead of writing the C1 plus the C2, I am going to write this ACB. ACB. Perfect, guys. This is exactly what they want us to do on this proof. So just enjoy the video. Just enjoy the video, guys.